Okay, everybody, let's start today's lecture. Let me... Okay. So, let me see if we have... Okay, 80 people is enough. Good. So, the last time I think we discussed about this simple program. We said that it has a function that takes two parameters, one integer and a double, and it returns a double. And we just call this function at this line like that, and there is nothing new actually regarding C++ edition. This is the same procedure that we followed in C. We declare the function and we call it, and at the end of this main function we can give the definition or the implementation of the total cost function. That's what we did last time, and you guys asked me a few questions. I think one of the questions was, can I get this implementation from this line, okay, and get this 6-7 lines of code and paste it in here. So do I have to implement my functions after the main function? Okay, I think that was the question one of you asked, and I'm going to ask you the same question. Can I do that? Can I implement that function at that line? Would it work? Okay, I'll start the lecture with a question.
It can't work.
Okay, let me turn my volume up. Okay, say that again. Who said something?
Hüseyin, it can't work.
So if it works, why do we prefer it this way? Why do we prefer the declaration of the function at the beginning, then we do the implementation? Why we said that we prefer it this way. I include the implementation at the end of the file.
Because we don't want anything too confusing before the main.
Because, yes, exactly. Because we don't want anything, I wouldn't say confusing, but I would say details. I don't want to see the details of the function implementation, okay? The important thing for me as a customer of this total cost in main function is how many parameters does it take, what are their types, and what does it return, okay? I am only interested in these things. So once I get that information, I can use it as a customer. Implementation is something in detail, and if I see the implementation, I may get confused. I may read into the function and try to use whatever inside the function, etc. So to be able to use a function, you don't have to know the details of it. You don't have to know the implementations of it. That's why we prefer it this way. Also, I mean, converting this single file program to a multiple file C++ program is so easy. Why? I mean, what is our current picture now? Let me show you. Okay, this is use the blue. Okay, this is our current structure. This is our file.cpp, whatever it is. At the beginning, I have the include statement. Include, I think, IO stream ... and then I have this double total cost and integer and double, right? And then I have my main function. Inside this main function, I make a call to total cost, and at the end I have the implementation of total cost. double total cost int t double, etc. So this is our current situation. It is easy to convert this to a header file. What is the header file again? Total cost.h. So what do? I move this part into this header file, and then I will have total cost.cpp, and I move this implementation to this total cost.cpp. And then of course I change my file.cpp so that I make an inclusion for this tc.h. So usually we prefer it this way. I mean, the ultimate way of compiling programs in C++ is have many files, and each file is responsible for certain module of the program, and this is the preferable way. If I do it that way, it is easy to convert from this structure to the other structure. Okay. So I mean, if you're going to do the things in a single file, then do it that way. But usually we suggest you do the multiple file C++ programs. That's what we said last time. Okay, good. We talked about these actually. There is nothing new in there, how to call functions. I'm going to skip this discussion because we're going to do this discussion later. I mean, when do we call them parameters and when do we call them arguments? We will come to this. Okay. Of course, functions can call functions. Actually, a main is a function too, right? Main is a function. And in C or C++ programs, if your program is an executable program, you have to have one main function. Okay. As we said, functions can call functions. That's what we have been doing so far. And main is not called by yourselves. Main is called by the operating system, right? You don't call the main function yourself. Main is called by the operating system. That's what we know so far. Okay. Declaring void functions using them is no different than declaring a double returning function. Void functions are kind of different. Why they are different? Because they don't return anything. So all they do is they just print out some stuff, send some information, etc. So I am not going to talk much about them. Here is a void function that show results. It takes two doubles and it prints them on the screen. Okay, and usually the book says that you don't have to use a return statement. Okay, but it is a good practice to include a return statement at the end without returning anything, just return. Okay. So we will talk about the return statements later when we talk about the recursion in a later chapter. Okay, when you write a function, we said that, for example, this is a function, right? It is enough for the compiler to see this line, the declaration line, to make a call to that function. The compiler doesn't need to see the implementation to make a call. Of course, for linking and building an executable programs, compiler needs to see the implementation, but to make a compilation, to compile some code that makes a call this function, all the compiler needs to see is this line. Okay. Usually we include these kind of declarations in our header files, and under the header files we write these kind of commands. We say that, okay, for this function to work, okay, the balance should be a non-negative account balance, and rate is the interest rate as percentage. Okay, so this one says that the precondition for this function to work, the balance has to be non-negative, and interest rate should be a percentage. Percentage means that 10%, 50%, 100%, etc. Okay, so these are the preconditions. before you call this function, make sure that this is satisfied. And post condition is, okay, post condition is amount of interest on given balance at given rate, etc., etc. And I do this and this and this, etc. Okay, so in your header files, after the function declarations or before the function declarations, you provide these kind of documentation for the reader of the code or the user of the code, user of the function, so that they would know what this line actually means. You are not the compiler. For the compiler, this line is enough. For the compiler, this line is good enough to make a compilation. But for the user as a programmer, you need to know what the function is doing. To know what the function is doing, you need to read the documentation. You need to know read the documentation, and this is documentation. So you provide your documentation when you write these functions. Okay, we talked about main, special function. Who calls the main? Of course, the operating system calls the main. That's what we said before. And I think last time I talked about you return an integer from main. So who gets that return value? Operating system shell gets the returned value. And how do we, if you are using a bash shell, so how do you know what value is returned from your main function in bash shell? I think we talked about this last time. Let's say my program is hello. I said dot hello, and it said something hello world. Okay, it printed hello world, and program ended, and it returns a 0. How do I get that number 0 from this bash shell? Okay, Fatih, yeah.
$$ question mark, I think.
Yeah, you would say echo. I have a variable named question mark. Question mark. What was the question mark? Oh, dollar question mark. Okay, dollar question mark. Okay. The dollar means that I have a variable, and you can you can make assignments to these variables. And for example, you could say set a, let's see if I can remember this. Is it correct? Okay. Echo $A. No. Set a for, I couldn't remember now how I set the value of a to. Would it work this way? Yeah. Okay. See, I am setting a variable, and it's when I say what is the value of a, then it says 4. So when I make this, and I know that ls return me an error value, and that error value is placed inside this question mark thing. It says that your error code is 2. It's not 0. So whoever wrote that ls program, they decided that they should return a 2 when the file is not found. Okay, good. So scope rules is the same as the C programming language. Okay, what is this? What is the scope? Just give me a definition. Give me a definition for the scope. What is the scope of a variable? What's the scope of a function?
Access range.
Access range, yeah, that's true. When you say I have an integer, let's say I plus 1, okay? So in order for me to use this I, it has to be defined, it has to be declared, okay? Here's a nice declaration inside a block. And after I define this one, the scope of this I is from the definition until the end of this block, right? That's the scope of this local variable. Okay? Usually, not usually, always in a function definition, implementation, if you have a function like this, you implement the function body in a block. Okay? In a block. Inside this block, you may have integers, and you use those integers. You may have doubles. Okay, and you use your doubles like this. So when that block ends, all those your local variables like I and D, they are all gone, they are all dead. So the block, the scope of this double D is here, and scope of this I is here. Okay. So these I and D variables are local to this block. Since that block belongs to function f, we say that those variables are specific to function f. Okay, they are only available within that block. Of course, I may have variables of the same name at different blocks. Let's give an example. If I have a function g that takes an integer k, okay, integer k, I say integer I, its value is 0. Let's say I printed out I like that. Then I decided that I am going to have a double I, its value is 0.0. And I will print out this I again. Okay, as you know, this is definitely a syntax error, right? The compiler says that you cannot do that because you have already declared this I as an integer. Now you are trying to declare it as a double. No, it doesn't work. You know, it doesn't work. How about this then? Can I do this? Can I open a new block? Is this okay? Is this okay? Can I do this? Is this compilable?
Yes.
Yes, it is. Yes, it is compilable. Why? Because there is a nested block in here. Okay, there is a nested block in here. The block of this double I is within the outer block, and they are two different blocks. And it is possible, yes.
But we didn't return anything.
What?
We didn't return anything.
Oh, well, yeah, well, okay. Well, so you are talking about the return. Well, in that case, my previous code was not compilable. Okay. I was talking about the blocks. Okay. So this is compilable. This is compilable because, there are two I's, but their blocks are different. And usually I can do that too. I can do this too. Okay. So there is one block, another block. These two blocks have nothing to do with each other. So I can have nested blocks, one block after each block, and each block can have its own variable set. Okay. So we usually prefer local variables declared this way. We don't like global variables. Global variables, they don't have blocks. They have their global scope. And we don't like the global variables because with the global variables, you don't know who is modifying the global variables. With this kind of structure, it is easy. I know that within this block, within this part, there is this double D. I may change its value. I may read this value, whatever I do. I know that after this block ends, they will go away. It will be dead. Nobody can modify it other than this function f. inside this function f inside this scope. With the global variables, the picture is not like that. The picture is not like that. Okay. Oh, there was a question. Kahramanar'da had a question like 10 minutes ago. Can we call main function to restart the whole program? You mean, can I call main function from the main function? That's called the recursive calling, of course, yeah, but that's not a good way of. I think I answered that one. You may call the main function from the main function, but that would make it a recursive function. It's not a good idea to write recursive main functions. It's not a good idea because every time you call the main function, you need to return from the main function, and you need a base case, and you know how to write the recursive functions, right? There is a base case, and with the base case, how do you know that you reach the base case? You get the parameter and you check it. So that's not a good idea to call the main function. Okay. So the functions, we know, I think I talked about it. For the compiler to compile a function calling, it needs to know the declaration. How many parameters it takes, the types of parameter, name of the function, and what it returns. Okay. As a user actually, as a customer for that function, all I need to know is this too. Okay. What does the function take? What it returns? What name it has? Also the precondition and postconditions. These are the things that I need to know to write a program on functions. So for me, a function is like a black box. What's a black box is like? Let me use a black pen then. The sign function, I know that it will take a double and it will return a double. Okay. I don't know how it calculates the sign of a given value, but all I know that I will call it, it will calculate the sign of the given value and return me a double. Okay, so this is like a black box for me. It's a black box. This is called procedural abstraction. This is called procedural abstraction. What it means is I abstract away, I hide away, okay, I hide away the details of how this function works. It's like a black box, okay? I am not hiding away the details because they are secret. Nobody knows the secret, and I don't want anybody to know the secret. No, it is not a secret. If you make a good research, you will know how to calculate the sign of a given value. That's no problem. But for me as a customer of this sign function, I don't need to know its details to be able to call it. Okay, this is called information hiding, and we are gonna use this principle a lot in object-oriented programming languages. Hide details of how a function does its job. All I need to know is how to use it. Okay, how to use it. And we are gonna try to hide as much information as possible from the customers or users of our software. That way, our software would be reusable, code reusable. Code reuse is something that we like to achieve all the time, okay? Don't try to invent the wheel all the time, okay? If the wheel is invented, then use it. If something that you have invented is good, it is reusable, then make it a nice function or nice class so that everybody else, including yourself, can use it later. To develop such functions or to develop such classes, okay, you try to apply this information as much as possible. hide as much information as possible. Okay, hide as much information as possible from the user. Okay, good. So this is called procedural abstraction. We are hiding the details of the procedures, and we are going to use this abstraction mechanism a lot. Abstraction is the most fundamental principle of object-oriented programming languages. Okay, good. So we will come to that one later. I talked about this global constant, global variables. We don't like global variables. Okay, global variables. Why? Because let's say this is a file. Let's say this is my program.cpp. Of course, I have my includes, etc. And there is a global variable named size, and its value is 10. And I have many functions. Int f, it uses size, maybe change the size. I have another function, global function. It outputs the value of size, etc. So as you see, I am using this global size inside this f and inside this g, right? I do this. The thing is that when I modify this value of size, okay, this function g will not be aware of it, okay, will not be aware of it. If somebody calls f, then later g, the function g will not know who changed the value of size. So, and in that case, for example, if I take this function f from this file and put it in another file, then since this f and g are dependent on each other because they are both reading and writing the same variable name size, it will be a bad situation because f assumes that g is going to be there and g assumes that somebody is going to change size. That's not going to be good. Okay, remember the principles of the structural programming. In the structural programming, we didn't like the goto statements. This is similar to goto statements. Okay, I don't know who changed the value of size. In the goto statements, there will be lots of branching from anywhere to anywhere. It's like somebody is changing the value of size and I don't know who's changing it. If there is a problem, I don't know where to look at. Okay, that's why we don't like global variables. We don't like them. Okay, we don't like them. But some people say that, what about this? Let's do this. A global, okay, a global structure, a global double tax rate, but I am going to make it constant, so nobody will be able to change it. In that case, this is kind of okay, because I know that nobody is going to change the value of this tax rate because it's a constant. Okay, we don't definitely like global variables, but sometimes we use these global constants named constants. Okay, and later we will see that in object-oriented programming languages, we don't like global constants either, and we should find some kind of a solution for this global stuff. Okay, in object-oriented programming languages, we don't like global variables, we don't like global constants, we don't like global functions, okay? We don't like functions like this f or g. They shouldn't be global. And since in C everything is a global function, so what are our solutions, and we will see later. Okay, so I think we talked about the blocks when we talked about the function blocks. Okay, all function definitions are blocks, we saw that. For for loops and while loops and etc., usually we use these kind of blocks if you don't have a single statement, more than one statement. Okay, the important thing here is that this integer counter CTR is a local variable for this for block, right? After this line, if I say, don't use the let me do this. Cout ctr. This is a compiler error, right? Because ctr is only defined within the scope of this for block, right? CTR is something local to this for block. We should know that. Okay, this wasn't like this previously. I mean, in the earlier versions of C++, the CTR continued living. Its scope continued beyond the scope of this for loop. But in C++ 98 and C++ 11, its scope is like that. Okay, of course, nested scopes are possible, and it's illegal, and we prefer it most of the time. Okay, good. So this is chapter number 3. We talked about the functions, how to define functions, how to declare them, how to implement them, what the procedural abstraction is. Do we have any questions about functions? The book likes to mention it this way. I mean, functions are two types, return a value or void functions. I don't like this definition. Functions are functions. Void is a type, is a specialized type and type. So there is no difference between a function returning void and integer, as long as functions are considered. Okay, we like this. Functions should be like black boxes. I don't have to know the details of a function to make a call to it, to call that function. All I need to know is the parameters, return type, and what it does. Okay, we just hide how details. Okay, and the function should be good enough, sufficient enough for itself to have all the data from a function. It gets data from the outside world using the parameters, and it does things and it returns something. Okay, it returns something. All the data comes from the parameters. You should not get any data from the global variables and etc. Okay, if all the data comes from the parameters and it doesn't use any global variables, then that means that I can easily move this function f into another file, or I can separate this f into more than one function. Okay, we talked about the globals and locals. I guess that's it for chapter number 3. If there are no questions, then I will start the new chapter, which is about parameters and overloading. Okay, again, we are talking about functions. We are talking about functions. We are going to talk about function parameters, and there is some new addition from the C++. We will talk about it, and we will look at this call by value, call by reference type of function calls, and function overloading and default arguments. These are new in C++. We don't have overloading and default arguments, and some stuff that we knew before, but we are going to look at them again. Okay, so in C, they told us that I'm sorry, I think I need to get this one. Okay, so in C they told us that, okay, all the C functions are called by call by value. Maybe they mentioned it a little bit different to you, but all the C functions are called by value. What does that mean? It means that if I have a function, let's say our main function. Inside the main function, I have an integer I, okay, its initial value is 7, and I'm making a call to function f and sending the value of I, and I will print out whatever is returned, etc. So the function f is a function that returns an integer, and it will take an integer k. I don't know what the function does, but let's say it just returns, let's say it increments the value of k1 and it just returns k. Okay, call by value means, you know that, right? Call by value means that when you make a function call like this, the value of I will be copied to the integer named k, local variable k. Okay, and this local variable k is a local variable of function f. K will live only inside this function. When the function is done, k will be dead. Okay, k is a local variable to function f. So call by value does this. Call by value says that I am going to copy the value of I to the variable k. This is call by value. We already had this in C. Okay, C++ says that I will have, this is in C also, this is in C++. C++ say that I will have another call type named call by reference. This is only in C++. Okay, with the call by reference there is no copying going on. The same variable that you are sending to function will be used, and if you modify it, and that will be modified. So let me try to do this way. C out when you say I. Okay, so this one will print what? It will print 8. This one will print what? It will print 7, right? Is that correct?
Yes.
Okay, so because I did not send the integer I to the function f. I just copied the value of I into this new variable named k. So there is a copying going on between I and k. I incremented the value of k by 1. It became 8, and I returned it. So when I modified the value of k, the value of I did not change. Why? Because those are two different variables. With the call by reference in C++, it is possible to send the variable itself, not the copy, but the variable itself. Well, you may say that I may achieve the same thing, simulated call by reference in C++. Remember, in C there is simulated call by reference. How do we do that? How do we do the simulated call by reference? We do it. Let me do this then. Let me copy it a little bit. Okay, so this is our f. I think I don't want to do. Okay, move it here a little bit smaller, and another one, it returns an integer. Let's say it is g. We say that g takes an integer pointer ip, and I would say, okay, since it's an integer pointer, I can follow this integer, okay, pointer, and I would say let's increment this value by 1, and I just return IP. Okay, this is G. So this one, G waits for you to make a call, okay, with the integer pointer, and when if I make a call with the integer pointer, okay, like this. Let's say if I do this cout, let me use a different integer now. Integer J7 again, and cout G address of J, and cout J. So I will, this one with, what does this do? This one would print, it takes an integer pointer and it increments the value pointed by that integer pointer, and it returns the incremented value. Of course, this one will print 8, and this one will print what? This one will print, maybe if I do it this way, cout J will print what? Okay, Atakan, what does it print?
9.
9. Why would it be 9? The initial value of J is 7. I send the address of J and increment the value of J.
Yes.
So what is the answer? What is the answer? 8.
8 maybe.
8 again. So if I do it this way, it looks like I am modifying the value of J. It looks like call by reference. It looks like I am sending the variable itself, not the value of it, but the variable itself. So that's why we call it simulated call by reference. So it is both possible in C and C++. So you already know this one, simulated call by reference. They teach you, okay? They taught you about this. And they taught you about the call by value. In C++ now there is a third way of calling functions. It's called call by reference. It's not simulated call by reference, but call by reference, okay? And we are going to see how. So there are kind of 3 ways of, actually 2 ways, call by value and call by reference. It's kind of, if you consider the simulated call by reference another third way. We are going to introduce a new way of calling functions called by reference. And references, we are going to deal with references a lot with the C++ programming language. Okay, so overloading and default arguments will come in a few minutes. Okay, so 3 methods of passing arguments as parameters. So this 3 is within quotes. Okay. It is actually 2, but if you consider it a simulated call by reference, okay. So, call by value, copy of value is passed. Call by reference, address of actual argument is passed. Okay, simulated call by reference. Actually, simulated call by reference is a call by value. All we do is send the value of the address of J, and that value is copied to this integer pointer variable IP. So there is a copying going on with the simulated call by reference. There is a copying going on. So instead of copying the value of I am copying the address of J, right? Instead of copying the value of J, I am copying the address of J. But at the end, it looks like I am modifying the contents of J, and that's why we call it simulated call by reference. C language does this, and we are going to use this a little bit in C++. Usually, when we do this kind of call by reference stuff, we are going to do the new way of doing it with C++. Okay, call by value parameters. The copy of actual argument is passed. Okay, that copy is a local variable inside the function. Okay, when that variable is modified, only the local copy changes. Okay, and this is the default method for C and C++. We did call by value all the time. Here is a example, a function named fee, hours worked and minutes worked. It looks like it returns the charges of hours worked hours and minutes worked minutes for legal services. So if I work like 5 hours and 30 minutes, if my hourly rate is $150, so I will calculate it and return it. Okay, so there is nothing new in this program. It is not any different than what we have seen before. Okay, so I get the values from the user. Cout, welcome to my office. My name is this. Give me your hours and minutes, and I will send those two values to fee function. It will return me the bill amount, and I will print the bill out. So all it does is call by value. Okay, call by value. See this minute worked. I just multiply hours worked with 60, minutes worked with 1, and I add them together. So I get total minutes worked. Okay, and it looks like that rate is not an hourly rate but quarterly rate. So for 15 minutes, I am charging you $150. So the quarter hours times rate is returned from this function. Okay, so this is the fee function. Call by value, nothing special about it. I think the book is trying to show you this is a local variable, and I am modifying the local variable. When I modify that local variable, after this function ended, my minutes did not change because I am not sending the minute itself. I am making a copy from this minutes, okay, to this minutes worked variable. Minutes worked is a new variable. That's why the value of this minutes does not change after I call that function. Okay, this is something you already knew. I did not say anything new in this program. Okay. Good. Since this is a local variable and its block is this, you cannot redefine them. If you do that, the compiler will give you an error message say that you cannot make a redefinition of the same variable in the same scope. Okay, this is something that you already know. Okay, let's look at this new way of making a function call by reference. Okay, call by reference. The syntax might be a little bit confusing for you because it uses old ways of making function calls with some other overloaded stuff. Okay, so this is a program. I am going to show you the program, but I think I need to take a break before I make a detailed discussion about it. I have three functions. Function number 3, show results. This is okay. It's called by value. I know this function. It just takes 2 integers, and I think it prints them on the screen. But these 2 functions, they take 2 integer references. We have never seen anything like this before. Okay? So get numbers and swap values. It says that reads 2 integers from the keyboard. So you make a function called get numbers. It reads 2 integers and places them inside this input 1 and input 2, and so you get the numbers. And the swap values gets 2 integer references, and at the end you swap their values. Okay, so let's take 10 minutes of break. After the break we are gonna look at how we call these functions and how we implement them, and how we can do the same thing with C programming languages. Okay, 10 minutes of break. It is 11:23 right now. Let's start at 11:33. Okay, 10 minutes.
Aradığınız kişiye şu an ulaşılamıyor. Lütfen daha sonra tekrar deneyin. The number you have called is not.
Okay, let me take the attendance first. I think I got the attendance. Okay, so this is the program. It says that you understand what it does, right? I mean, it gets two numbers from the keyboard. GetNum does that. Okay, it gets two numbers from the keyboard, and then it swaps the values of these two integers, and it shows the results on the screen. Without going into the details of how we do this in C++ with the references, let's write the same thing in C actually, right? I mean, let's write the same thing in C. In C, void get numbers. Since I am going to use simulated call by reference, an integer pointer I1 and another integer pointer I2. Okay, I will say, okay, cout give me two integers, okay, and then cin I1 and I2, return nothing. Okay, so this is our swap values. This is our get numbers function in C. So of course in C, if this is if this is how you call the get numbers in C++, in C it's going to be get numbers address of first num, comma, address of second num. Okay, so this is how you call them. So this is get numbers function. Let's write the swap values function. Swap values function is going to be very similar to, I think you have written functions like those before. I'm trying to find a good place to put this in. Okay, good. Let's write the swap values. Void swap values. Okay, it will take again two integer pointers, integer I1 and integer I2. Of course, I need a temporary integer, int t, and the initial value of that integer t, let's make it I1. Now I copy the value of I1. Maybe I can just I1 guess the value of I2, and I2 guess the value of t, and I just return. And again, how do I call this function? I call this function as swap values address of first num and address of second num. Okay, this is exactly the same program. For the third function, I am not going to do anything. This is exactly the same program that you have written in C. Okay, do I have a connection problem? You cannot hear me? Sean, okay, good. Okay, people don't write anything in Turkish. This class is 100% English, and you're gonna speak in English, okay? So get numbers and swap values are written like that in C. Let's see how we are doing it in C++. In C++, it said that this get numbers and swap values, they will take references. They are taking references. They are not taking integers. They are not taking integer pointers. They are taking integer references. And this is how you call a function that takes an integer reference. You just send an integer. You might say that I cannot see any difference between a function that takes integer values from a function that takes integer references, right? I mean, line 14 and 15, they look exactly the same. They are very, very similar. You just make a function call and you send two variables, okay? But those functions, okay, at line 6, it says that I am taking a integer reference. I am taking an integer reference, okay? So when you make a function call, you actually, by looking at just the function call line, you don't see if you are sending a reference or an integer itself. You need to check the function declaration. So it takes two the numbers from the keyboard and swaps their values and prints them out. Let's see one example how it works. Then after that we'll come. Okay, enter two integers 5 and 6, and in reverse order the numbers are 6 and 5. I just swap their values. Let's see how those functions are implemented. The last one, show results. There is no new thing in here. Everything is, everything is C way of doing it. Two integers, output them. Let's look at the get numbers function. Get numbers, okay, get numbers. It takes two references, not pointers, but these are not pointers, okay? These are references. And once you get the reference, whenever you refer to input 1, you are referring to first num, okay? When you refer to input 2, you are referring to second num here, because get numbers is called that way, okay? So input 1 becomes a reference to first num. Input 2 becomes a reference to second num, okay? So input 1 is not a new local variable. It is just another name. It's just another name for first num. Input 2 is just another name for second num. When we come to swap values, okay, not that I did not change the values of input 1 and I changed the values of input 1 and input 2 using the stream extraction operator, okay? So when you change the values of input 1 and input 2, first num and second num is going to be changed. The same thing here with the swap values, okay? When you change the value of variable 1 and variable 2, first num and second num in the main function is going to be changed. This is how they define the syntax. This is how they design the whole mechanism of references. Okay, and we call this call by reference in C++. In C we don't have call by reference. In C we have simulated call by reference. Okay, and this is how we did that in C. You might say that, okay, well, what is the advantage of this in C++? I mean, I was fine with pointers. I was fine with simulated call by reference. Yes, that's true, but this is like, it's like printf and cout. Okay, this was required for some operator overloading stuff. Other than that, you didn't need it, but it is in C++, and we instead of calling functions with this simulated call by reference, we call functions with call by reference mechanism. Sinan has a question: is it better call by reference than simulated call by reference? Well, in terms of performance, there is not much difference. It is the same thing. But in terms of compatibility with the other C++ programmers, we usually prefer call by reference instead of sending the pointers. Okay, we usually prefer call by reference. Well, it's true that some people like this idea. When I make a function call, I know that this get numbers function is going to modify this first num and second num. I know it from the code, but from looking at this code, you don't see the difference between swap values and show results. One of them is call by reference, call by value. Yeah, that's true, but this is how the things are designed. So we are going to use call by reference as much as possible. Okay, good. So at first, this is going to look a little bit confusing. It looks like there is a pointer operation. No, it's not pointer, it's ampersand. And this is a reference. Okay, it's a reference. Performance-wise, it is the same thing. Call by reference or simulated call by reference, there is no difference in terms of CPU speed or memory utilization, and etc. Question: is this changing values, not address? Nobody's changing address, no. This one is not changing address. Get number, when you do it with this C programming language, simulated call by value, simulated call by reference, you did not change any addresses, you just send the addresses. Okay? Nobody's changing any addresses, and call by reference does not change addresses either. Okay? But if you like to see it that way, when I make this function call line 13 get numbers first num, second num, okay, the address of input 1 and the address of first num as integers are the same. Okay, should we use call by reference instead of simulated one in our homework? Well, I did not. Well, you could use it. Okay, you could use whatever I taught you in the classes until the submission date. If you like, yes, you should use the reference, call by reference. Can we use? Yeah, okay. Doesn't matter. You know both of them. Simulated call by reference is not a C library thing. It's part of the language. You may use both of them in your homework. Okay, let's move on then. So what do you really pass in? A reference back to caller's actual argument. Okay, so you are sending a reference. Reference means that you are actually sending the integer itself. You may think it that way, but in actuality, instead of you are doing sending the address and using the pointers yourself, the compiler is doing all that for you. Okay, the compiler is doing the simulated call by reference for you by sending the pointer and using the pointer stuff to make all those changes, but you don't see it. So as I said before, performance wise, in terms of CPU time or the memory usage, there is not much difference. Okay, there is not much difference. Okay, so sometimes people say that, okay, okay, I like to have an integer reference, but I promise I will not change it. Okay, I like to have an integer reference, but I promise I will not change it. So that means that whatever I send to this function is going to be sent as reference. Okay, there will be no copying, no copying. Okay, but the variable stuff will be sent. There is no copying, so that means that I am saving some CPU time, right? I mean, when you do the copying will take some time, but you say the outside world that I am not going to change any of your variables, okay? So I will take 2 integer references, but I promise you I will not change that, okay? It protects the data, and you still use the call by reference or pass by reference. If you try to change any of these parameters, the compiler will give you an error message saying that you promised me you were not going to change anything, but you are changing it. Okay. Okay. So the question comes to mind is, if you are not going to change the values of this parameter 1 and parameter 2, why don't you just use regular call by value? Just call this function using call by value, and in that case, even if you change the values of parameter 1 and parameter 2, the caller function's integers will not change, right? Why don't you do it that way? The answer is this: I don't want to do this copying. Okay, copying is expensive. Well, I mean, integers is either 4 bytes or 8 bytes. For integers, it doesn't matter much. But if you are sending something large, something big, then copying is expensive. Copying is expensive. So usually you're going to see people passing arguments like this a lot. You're going to send constant references to your functions. Then they will not be integers, doubles, or characters or booleans, but there will be large variables. And by large variables, what I mean is for example, a string. Let's say a string, there is a 500 characters in it. You don't want to send that string using call by value, but you are going to send it using call by reference. Since I don't want to change my parameter argument, then I'm going to send it constant call by reference. So you are going to see this a lot in your programs. Okay. So remember the slide that I skipped? Emirhan has a question. Is making the function const same as making each parameter const? I don't know what that means. What is making a function const, Emirhan? What is making how do you make a function const? This is a function, integer f. It takes a constant integer reference a. How do you make this function const? Oh, I mean, that means that it returns a constant integer. It doesn't mean that. Oh, okay. The return type is const. No, I mean, this one says that I am going to change I am going to send you a constant integer. I am going to return a constant integer. You are not supposed to change this constant integer. Okay? That's what it means. And actually, it doesn't make much sense. I mean, how are you going to change? Let's get this one. This is funny. F, let's say this function returns an integer. F2, if I'm going to change it, can I do this? Even if it is not a const. Can I do this? No. You cannot change whatever this function f returns. It returns a value. You cannot change the values, right? This is already an error. So how do you use this const returning stuff? Let's say I have a function. Okay? I have a function, let's say G. It takes a string A, B, C, and it returns a, okay, let me do it this way. It takes a string str and it returns a string. Okay, so if I call this function G A B C, it will return me a string, right? What can I do with the string? Maybe I can say the second element of that string is going to be 10. Okay, in this case, whatever this function is returning, I am going to modify it with the index operator. If you don't want this to happen, if you don't want this, okay, then you put a const in beginning. Okay, I am returning a constant string. You cannot modify whatever I am returning. Okay.
Hocam,
Yes.
it will return string. How can we change it with integer?
That's a good point. I thought it's a vector. Okay. How about this then? A. Okay. It returns a string, and the second parameter of second element of that string is a character, so I am modifying it. If you don't want this to happen, if you don't let your customer to do it that way, you return a constant string then. Okay. So these kind of problems doesn't happen with the fundamental types or the regular types. It happens with the complex types, like the types that are added later to the C++. Okay, good. I get confused, so it should have been int function. Eminhan, nobody knows what member function is. I mean, you are confusing yourself. Did I talk about member functions? Does anybody know about member functions? No. Don't get too far away, okay? Nobody knows about the member functions. Okay, when we come to member functions, we'll talk about it. Okay, so let's look at this parameters and arguments, and we talked about that before. Actually, we just skipped it. We said that what is argument, what is parameter. When you say parameter, actually, those are the formal parameters in the declaration of a function. Okay, this is a parameter. A is a parameter for function f. Okay, A is a parameter for function f. What's an argument? Argument is this. Okay, 2 is an argument when you make a function call to f. Okay, so arguments are the ones that you fill in when you make a function call. Parameters are the inputs to the function when you make the function declaration. Okay, so the arguments, we call them during function call. Parameters, we call them parameters when we do the function declaration. Okay, so these are the regular meanings of parameters and arguments, but usually people use them interchangeably, and I usually don't use the term argument much. I always call them parameters, but the correct term is arguments are used. The term argument is used when you make a function call. The term parameter is used when you make a function declaration. Okay, so just make it clear and let's move on. It is possible to have this kind of a mixed parameter list, mixed call, it needs a integer reference, an integer value, an integer reference. Okay? Integer reference, integer value, and integer reference. Good. So you are going to call it accordingly. You will know that the second one is a call by value, call by reference, and call by reference. By the way, if we go back to this program, simple program, and you would know that this would not be possible. Get numbers 3 and 7, or maybe even this one would be even better. Swap numbers 3 and 7. No, the compiler will tell you that I don't know how to get a reference of a constant, right? The compiler will tell you, I don't know how to get a reference of a constant. Otherwise, you're going to change the values of two constants, 3 and 7, swap their values. That's not possible. But this one is possible. This one is possible. Why? Show results 3 and 7. This will work, right? This will work. Why? Because 3 and 7, the values of 3 and 7 can be used to call this show result function. Okay, show result function. So why did I say that? I said that because when you do this mixed type of parameter list, when you make a mixed call, let's make a mixed call. Mixed call A, 7, C will work. Why? Because this one A, okay, will be sent as a reference. 7 will be sent as call by value, and C will be sent as reference again. So this is possible, but this will not be good. Mixed call 1, 2, 3. This will be bad. Why? Because I cannot get the references of 1 and 3. I can get the value of 2, but I cannot get the reference of 1 and 3. Okay? Good. Okay, so the formal parameter names are important. As we said before, all the identifiers that you are using in your program should be meaningful names. And usually the parameter names and the argument names, very often they should be different. Okay, the parameter names, here, go back to our program again. Okay, first num and second num are good argument names. Variable 1 and variable 2 are good parameter names for swap values, because swap values is supposed to change the values of two variables. Input 1 and input 2 are good parameter names for get numbers. Okay, so as you see, the names of parameters of get numbers, swap values, and show results are very different, because for get numbers, input makes sense. For show results, output makes sense. Swap values, variable 1 makes sense. But for the arguments, I have two integers, first num and second num, and I am using the same integers for all the functions. Argument names are different, and this is expected, and this is the preferred way of doing it. So if you end up using the same parameter names and the argument names, that means that you are probably making a mistake. You are confused about what your function does. You are confused about how you make those function calls. Okay, so choose meaningful parameter names and don't try to use the same parameter names as the arguments. Okay. Okay, any questions so far about the references? We are going to talk about the references a lot. By the way, nobody asked it, but you could return a reference from a function. You could say that, okay? Remember when I say this, if a function returns an integer, let's say f takes an integer and it returns an integer. If I do this, f2, okay, this is okay. Integer a gets the value of f2. That's fine, no problem. But this is bad, right? Integer, this is bad. f7 gets the value of 71. This is bad. How are you gonna assign 71 to some value? That's bad. But how about this? How about this? If I return a integer reference from this function g, it takes an integer. Okay, it takes an integer. Integer b gets the value of 7. That's fine. This is fine. This is also fine. G8 gets the value of 11. Okay, this is fine too. It looks so weird. How can this happen? This one is returning something and assigning something to it. Yeah, because it is returning a reference. It is returning a variable itself. It's not returning a value. It's returning a variable itself. So references are useful to do this kind of thing in C++. I cannot do the same thing in C because there is no reference in C. But in C++, there is a reference, right? There is a reference. And if I return a reference from a function, I have to be very careful about this. We will see it later. I can do this kind of stuff. And this will be very useful later when we do the operator overloading. Okay, any questions about references? If there are no questions, then I'm going to start talking about overloading, which is an important concept in C++ and many object-oriented languages. Any questions? Okay, if there are no questions, then I will continue. Overloading. Let's make a definition first. Function signature. Maybe they talked about this in your C classes. Maybe they did not. Doesn't matter. Let me make the definition of a function signature. Function signature is the function's name and the parameter list. Okay? For each function, its signature should be unique. No two different functions can have the same signature. Okay? Can have the same signature. So if I have this function that returns an integer, if I have a function f that returns an integer and it takes a double and a string, okay, the signature of this function is f, the name f. Also, the order is important, a double and a string. Okay, so this f plus double plus string is the signature of this function. No two functions can have the same signature. Okay, so this is the C++ signature. Okay, function signature for C++. Okay, in C signature. Okay, in C signature of a function is just its name. That's it. Okay, C does not consider the parameters, their types, their order, their numbers as a signature. But in C++, in this function signatures, I have the name, their parameters, number of parameters, the types of the parameters, the order of the parameters. They are all part of the signature. That's why in C, you cannot have two functions having the same name. Okay, because if you have two functions having the same name, that means that their signatures are the same. In C, you cannot have a function f that takes an integer, another function f that takes two integers. In C, this is not possible. Let me put this in a box. C signatures. This is not possible in C because I have two functions with the same name. That means that their signatures are exactly the same. But in C++, the definition of signature is different. The signature says that function's name, also the parameters. So in C++, it is possible to have two functions like this, integer f, double, and another one, an integer f with a string. Okay, all these three could exist at the same time in C++. This is C++. Okay, because the definition of signature is different in C and C++. Okay, so it means that in C++ I can have many functions named f as long as their parameters, parameter types, parameter orders are different. Okay, so that's something new, and this is called overloading. Why we call this overloading? Because we are giving many new meanings to the same function name f. Okay, we are overloading it. We are loading it with new meanings, and all old meanings are kept. We are not getting rid of them. I can't do the same thing in C. In C, if the function name is f, there could be only one function named f. Doesn't matter if the parameters are different. Okay, so this is called overloading. And let's look at this example. In C++, I may have two functions at the same time in the same file, in the same program, named average. One of them is taking two doubles, the other one takes three doubles. Okay, this one takes two doubles, adds them and divides them by 2. This one takes three doubles, adds them and divides them by 3. Same name, two functions. This will not compile in C, but it will compile in C++. Okay, good. Any questions? So it looks like, in C, sometimes, how do I do the same thing in C? In C, you cannot have them at the same time. Usually people say that, okay, this one is going to be called average 2. This one is going to be called average 3, right? That's how we do it. That's how we did it in C. We just changed the name of the function. Remember the C function tangent? Let's look at this. C function. Okay. So there is a not tangent but arctangent. There is a function called arctangent 2. Also there is C function. Also there is another one, arctangent. Both of them calculates the arctangent. One of them takes a single parameter. This one takes a single parameter, just a double. This one takes 2 parameters. Since these two functions come from the C programming libraries, they could not call this function just a single arctangent. They have to change the name so that their signatures are different. In C++, we don't have to do it that way, okay? We say that, okay, one of them is arctangent, that takes a double. The other one is again arctangent, that takes 2 doubles. Double and double. Okay, same function working on 2 different types of data. This is called overloading, and we are going to do this a lot. And this is a preferred way of making function, naming your functions in object-oriented programming, your functions or similar stuff, because the compiler is smart enough to call which function, okay, from the definitions. Here is an example that shows you how to call these 2 functions. If you call this average with 2 parameters, compiler is smart enough to call this function. If you call that function with 3 parameters, the compiler is smart enough to call this function. If you call it with average 1.0, what happens? What happens if I make a call with a single argument, 1.0? Anybody? It's a compiler error. Why? It says that I could not match the signature of this function call with any function definitions. All the signatures I am looking at, yeah, average matches, but all the averages that I know will take either 2 parameters or 3 parameters. I couldn't find an average that takes a single parameter. Okay, single parameter. Okay, good. So overloading is something like that, and we prefer using overloading. Of course, with the new mechanism always, there might be some problems. Like what kind of problems you might say? We will see it in a few minutes. Okay. Let's look at this example. And we will come to the rules. Let's say I have 3 function f's. They're all f. Okay. And one of them takes an integer, a double an integer, and integer. Okay. When you make this call, f9899, of course, the perfect match is this one, integer and integer. I will make this function call. When you make a double an integer, it will make this call 2. How about this one? Both of them are doubles. This is not a perfect match. This is not a perfect match. But I can make this call. Okay, maybe I can convert this 4.3 to an integer and call this one, or maybe I can convert 5.2 and call this one, and maybe I will convert both of them and call that one. Which one am I going to call? So with the overloading, these kind of problems might happen. These kind of problems. I don't know which one to call. Okay. So what kind of compiler error do you think we will get? Are we going to get a compiler error for one of these, or are we going to get a compiler error for this one? Any ideas?
We will get an ambiguity error.
For which one? Line 3 or line 2, line 1, or this one or that one and that one? When do we get? I mean,
function call.
Function call, right?
For the third function call.
Yeah, it is not
the
the error is not with the function definition, but error is with the function call, right? When you make the function call, the compiler is confused. The compiler doesn't know which one of those should you call, because the signatures of these three are different. You are allowed to overload them, okay? But when you make a function call, you need to be careful in there. So don't make these kind of function definitions. They are confusing, intermixing like these doubles and integers and that kind of stuff. But if you like, you can do that kind of stuff. So how does the compiler resolve this kind of situation? It first does that. Is there exact match when you make a function call like this one? Integer, is there an exact match? Yeah. Here is the exact match. I make this, okay? Again, the same thing for this one. Is there an exact match? Yeah, number 2 is exact match, double and integer. If I cannot find the exact match, can I do a compatible match by converting an integer to double or double to an integer? Promotion or demotion? Converting an integer to a double is a better way of doing it, because you do no loss of data, but sometimes you do it with the possible loss of data, demotion. Okay, and none of them works. Or if you do this, if there are more than one way of calling that function, then in that case, compiler would produce an error message. Okay, this is how you resolve the overloading situations. Good. Did I skip anything? Overloading pitfall? Yeah. By the way, since overloading is possible, you might think that from now on I am going to call all of my functions f with a string, f with an integer, f with a double, f with everything, because the parameters are different, right? This is not a good idea. Okay, don't use overloading for this kind of confusing name calling. Okay, just because compiler lets you call them all f as long as the parameters are different is not a good idea. Okay, this is a good idea because both of them are calculating the average. Okay, both of them are calculating the average. So using the two different functions, naming them average is a good idea, but naming very different functions doing very different things as f is not a good idea. It will make things confusing. Okay, it will make things confusing. Don't do that. Okay, I think I am out of time, and I think maybe I should stop here. And okay, I think I will stop here, and tomorrow we will continue from this point. If there are no questions, I will stop. Otherwise, if you have any questions, you may ask me now.
So we talked about overloaded operators before. For now, we can overload functions.
Yes.
Can we overload operations?
Yeah, sure. Yeah, well, there is a complete chapter about operator overloading. Okay, there is a complete chapter about operator overloading. In that case, we are going to give new meanings to a plus operator, minus operator, index operator, assignment operator, and it will be clear in that case that why we are talking about this operator overloading thing. Okay. Okay, thank you. I have to go now. If you have any questions, tomorrow we will continue.